Hello, in this tutorial I'm going to talk about descriptive statistics in detail. As I already discussed, what is descriptive statistics? It is a method to organize, summarize, visualize and collect the data and represent so that we can get some actionable information out of the data. So, descriptive statistics are further mainly divided by two ways we can understand on a raw data. So when you have a raw data, descriptive statistics are further divided on the basis of two ways. The very first is called based on measure of central tendency. And also it is further divided with the based on measure of dispersion. So when I say measure of central tendency and measure of dispersion, so we can understand that, so measure of central tendency is, let's suppose you have any form of data. So when we wanted to know about, let's suppose you have a data and this further data you want to understand from how your data is from the central line, central position. Okay, how your data is, can be related from your central position. This is called measure of central tendency. Okay, so how close your data from the central point. Okay, so this is a median point. So for this we try to find out these three things, that is called mean, median and mode. I will be discussing these things in detail. So when we try to find out based on the measure of central tendency, we try to understand this way that let's suppose you have a suspended pipe in horizontal, how your data and where it is more based on the inertia, based on the central gravity, how the data is further tilted. So like a rope is tied at a center of gravity and the rope is further tied from the center of gravity. So these two position based on the where the maximum amount of data is distributed. So similarly, when we wanted to find out data how distributed, is called measure of central tendency. And when you wanted to further try to understand how your data is actually dispersed, like if I tell you, so when we try to understand how data is further divided based on the distribution of data, like how data is divided or distributed. Okay, so this is the distribution of data, or you can say dispersion between the data. Okay, so that is called measure of dispersion in under descriptive statistics. So in this in measure of dispersion, we will try to understand about our range. We talk about outlier. We talk about variance and deviation between data. We talk about standard deviation and skewness in the data set. So these are further things we're going to follow up under measure of dispersion. Now let's move further. So when I say measure of central tendency, so we try to talk about that the best central position of frequency of distribution of group of data, that is mean and then median and then mode. So if I have to explain you what is mean, we can understand that mean for ungrouped data is obtained by dividing the sum of all values by the number of values in the data set. So let's suppose we have a data x 4, 5, 6, 7, 8. So we can find out the mean by adding all the values by the total number, that is 1, 2, 3, 4, 5. So this is going to be divided further as the mean population of data, and similarly for sample data sets as well as. We will be talking about first median. So if I have to tell you about median, median is also called as the middle term in a data that's been ranked in increasing order. The calculation of median consists of following two steps. First, we rank the data in an increasing order, then find the middle term in a data with n values. So the value of this term is called median. And let me give you an example. Let's suppose you have a data called 4, 5, then 6, 3, 2, 1, 8. So the very first step is I will first put in a order. So that is 1, 2, 3, 4, 5, 6, 8. So generally we will calculate whether it is odd or even. Odd or even. So if I calculate the total number, that is 1, 2, 3, 4, 5, 6, 7. So that is odd. So if it is odd, it will be a middle value. So in right side we have 3 value and 3 value. So 4 is going to be odd for us. If it is not a even number, let's suppose we have one more value called 9. So what we'll do, the middle number, these two both middle number, that's called 4 plus 5, will be divided by these two value, that will be 9 by 2 will be my median. This is called median in our data set. So the advantage of using median as a measure of central tendency is that it is not influenced by outlier. Okay. So mode, if I have to tell you about mode, so mode is the value that occurs with the highest frequency in the data set. Okay. Like how many times a value is occurring will be a mode for us, and a mode can be a unimodal mode, bimodal or multimodal. So data set with only one mode is called unimodal. Data set with two modes is called bimodal. Data set with more than two modes is called multimodal. One advantage of mode is that it can be calculated for both kind of data, quantitative and qualitative, where the mean and median can be calculated for only quantitative data. Okay, so this is about our mean, median and mode. Now let's talk about outlier. Outliers are important to understand. See, let's suppose you have a data, any kind of data. Okay, you are measuring some certain information, that is let's say you are taking some healthcare data for a person, that's called blood pressure of multiple patients. Okay, so you are taking 1, 2, 3, 4, 5, 6, 7 and so on, 100 of data you have taken. So you have taken the blood pressures around 80 bpm, 92 bpm, so on, so on, so on, so on. Suddenly you have taken a data that's called 800 bpm. So see what I'm trying to tell you, how do you understand outlier? So if we have 800 bpm, that is something unusual. Okay, any unusual information, either it is very high or very low compared to other data is called outlier for us. Okay, and that is not applicable for our analysis further. So also one more example, value that are very small or very large relative to the majority of value in the data set are called outlier or extreme values. Like table below list that 2000 population in 1000 of 5 Pacific states. Notice that population of California is very large compared to the population of other 4 states. Hence, it is an outlier, and show the inclusion of this outlier affect the value of mean. I hope you understood. Now, let's talk about our based on our measure of dispersion. Okay, so in order to give you the idea based on measure of dispersion, we'll be talking about few multiple other stuff. Let me show you. So based on measure of dispersion. Based on measure of dispersion, we have data, based on measure of dispersion, we try to understand different types of statistics, and these types of statistics that we try to find out is called, first I'll let you know about range. Okay, we talk about variance. Okay, we talk about standard deviation. We talk about skewness in the data sets. So let's talk about range first, and then similarly I'll talk about variance, standard deviation, and skewness. So when I say about range, range is the size of the smallest interval which contain all data and provide an indication of statistical dispersion. So range is can be calculated as the largest value minus the smallest value. The disadvantage of range is that range, like the mean, has a disadvantage of being influenced by outlier. Its calculation is based on two values, only the largest and the smallest, and we will talk about now about our variance. So in order to understand about variance and standard deviation, we can understand that variance can also be defined as, variance is the sum of the square of deviation from mean. So variance is also called as variability in the data. Okay, so variance is the sum of the square of deviation from mean, and the difference or deviation within the data is known as variance. And the standard deviation is the you can also call as the most used for measure of dispersion. Value of standard deviation tells how closely the value of a data set are clustered around the mean. Okay, so if I tell you about variance first, variance can be that is standard deviation. Standard deviation whole square is called as variance, and that is also called as this. So variance, we can calculate variance as, that is, as I say, it is the sum of the square of deviation from mean, that is x minus x mean whole square by n. Okay, this is called as variance. And standard deviation, we can say that standard deviation is nothing but the under root of this. So standard deviation is nothing but under root of x1 minus x mean whole square by n. That is called standard deviation. So I hope you can understand from this. That is, population of standard deviation is this, and then we have sample standard deviation. You can call it like this way. So we understood about variance and standard deviation. Now let's talk about our skewness in the data. So in order to understand skewness, let's talk about skewness can be it is opposite to symmetry. Okay, so we can say that a symmetrical data is something look like this, which having a bell curve. Okay, this is called a symmetrical data. Okay, so skewness is nothing but it's a opposite of symmetry. Okay, and we can also call it called lack of symmetry. if we have to find out, there is a Pearson coefficient of skewness that is called SKP. This is nothing but it's a mean minus mode by standard deviation. So we can call is always the practical value you will get of a skewness coefficient is in between -3 and SKP will be 3. Okay, and for symmetrical SKP will always remain 0, means where mean is equal to mode equal to median is called symmetrical position, and this is not having any skewness. So skewness here is 0, skewness coefficient. Now skewness, negatively skewed data will be little slightly deviated in the left side, and positively skewed data will be little slightly deviated in this side. So this is a, you can say that negatively skewed, and it's a positively skewed. Okay, and this is, in this condition, mean mode is greater, the outmost greater than median, and then we have mean, and the opposite of this, that is called mode, then median, and then mean. So this is something that we need to understand. Okay, so this is what about skewness. I hope you understood this. So in the next session I'll be talking about further about probability distribution. Thank you.